Hello class. Got a question here regarding the CAT for this week, which was solving the quadratic equation using one of the following methods, either factoring, completing the square, or the quadratic formula. And one of the students requested to see these work out, and so I've put this video together, and hopefully you guys will like it. So the problem we were given was 2x squared plus 12x equals 4. So I'm actually just going to jump over here and we'll write that down. So we got 2x squared plus 12x equals 14. That's the problem. And so first method we're going to use factoring. So first thing we should do is we should get everything on one side, put this into the standard form of ax squared plus bx plus c. So I got 2x squared plus 12x, get my 14 over here by subtracting it from both sides, and I get 2x squared plus 12x minus 14 equals 2. Okay, well we're going to use the factoring method, so the first thing we notice is that there's a GCF, so I'm going to go ahead and pull out that GCF, which is 2, and the reason I know that is all of these numbers up here are even, so I get 2 times x squared plus 6x minus 7 equals 0. My next step is going to be to find the two factors, and I'm just rewriting this because it's kind of messy. Two factors of 7 that when added or subtracted equals positive 6. And again, it's negative 7. So what I find, to get negative 7, I have to either multiply negative 7 times 1 or positive 7 times negative 1. Well, in this case, positive 7 plus negative 1 gives me the negative 6. So that's our magic combination that we want to use. So we want x plus 7 times x minus 1. Still need to bring back our factor of 2 and set it equal to 0. And now what we want to do is we want to set our factors equal to our opposite side, our 0 here, and see which roots come back as being true. So the first one we get is 2 equals 0. Well, that's obviously never true, so that one's done. We have x plus 7 equals 0. Well, that is only true when x is equal to negative 7. And then I've got x minus 1 equals 0. It's a weird one. X minus 1 equals 0, and that's only true when x equals positive 1. Okay, so we found x equals negative 7, x equals 1. If we wanted to solve with factoring, we'd be done. But we also want to solve using the completing the square method. So completing the square, I'll try and work in over here. But completing the square is asking us to find a perfect square trinomial that we then use the square root property on to find a single solution for x. So let's go ahead and see what that looks like. Again, we start off with our 2x squared plus our 12x. And I'm going to jump to moving the 14 over, set it equal to 0. Now the first step when we complete the square is that we have to get this leading coefficient equal to 1. So the way we do that is we divide everything by that leading coefficient. And we get 2 divided by 2 gives us a nice single x squared. 12 divided by 2 gives us 6x. And 14 divided by 2 gives us negative 7. 0 divided by 2 gives us 0s over here. Now I need to use completing the square. Well, completing the square says, again, I want to make a perfect square binomial. And the only way to do that is to have x plus a number, the quantity squared. Well, I can't do that. We know in this factors it's x plus 7 times x minus 1. So what we're going to have to do is we'll have to move this 7 to the other side. X squared plus 6x. I'm going to leave a little box here open, equals positive 7. And now our goal is to find what number can put right here to turn this left side into a perfect square. So we're completing this perfect square, okay? So how do we do that? Well, what we're going to use is we're going to use what we learned from FOIL and apply some of that knowledge to find this 6. So what we see is the shortcut rule is we take this 6, we divide it by 2, which gives me an answer of 3. We take that 3 and we square it. So we divide by 2, we square it, and we get the value of 9. Okay? So this is our little cheat for finding what goes in this box here. And we get x squared plus 6x plus 9 equals 7. Okay, now the first thing that should jump out to you is, hey, I added 9 to the left side. Don't I need to add 9 to the right side? That's exactly correct. We need to keep this equation balanced. If we don't keep the equation balanced, it's no longer the same equation that we started to work with, okay? So, what did we do here? Well, x squared plus 6x plus 9, as I mentioned, is going to factor into a perfect square binomial. And it's going to factor into x plus 3 quantity squared. Okay, now this 3 should look familiar. The 3 right here is the same as this 3 right here. So you can always learn whatever this number divided by 2 is going to be our binomial. And the reason we squared it was because when we square this last term, we get this 9. So we divided by 2, we squared it. This is how all this kind of works together. We get x plus 3 squared equals 16. Now I can go into, if we have additional questions, I can go into the actual proof with where this divided by 2 and squared comes from, but hopefully that will suffice. Just let me know if you need more information on that. But it gets us to this x plus 3 quantity squared equals 16. And now I'm going to apply my square root property. So the square root property tells me all I need to do is I can take the square root of each side of an equation, and that equation is not changed. Its balance is not changed, its statement of equality is not changed. Okay, well we know if I take the square root of a square, these two things are going to kind of cancel out. So let me switch back to my blue color, and what I get is I get x plus 3. I know the square root of 16 is 4. And what I need to be careful of here is it's not just 4, it's actually positive and negative 4, right? Because negative 4 times negative 4 is also 16, so I got to keep both of those in check here. So now we just need to solve for x. Subtract 3 from both sides. I get x equals positive and negative 4 minus 3. Positive 4 minus 3 is equal to x equals 1. X equals negative 4 minus 3. Negative 4 minus 3 is negative 7. So I get x equals negative 7. What do we know? We got the same answer both ways, so we know we did something right. Perfect. The last method we want to work through is the quadratic formula. So I'm going to put the formula for that here. And the quadratic formula is x equals plus and minus, or excuse me, let's go ahead and do that. So x equals negative b plus and minus the square root of b squared minus 4ac, all of this over 2a. And now you'll be saying, well, I don't see a b, I don't see an a, I don't see a c. Again, this is coming from our standard form equation, which I referenced earlier, which is ax squared plus bx plus c equals 0. So what we're going to see, the easiest thing for us to do is all we need to do is isolate which numbers are a, which are b, and which are c. So if I come back up here and I come to our original problem, what looks like a is equal to 2, b is equal to 12, and c is equal to negative 14. Okay, now that I know this, a is 2, b is 12, c is negative 14, I can plug it into this formula. So let's go ahead and do that on a nice new clean sheet of paper. So I get negative b plus and minus square root of b squared minus 4ac, again, all over 2a. This is, again, equal to our x value, our root. Okay, so let me rewrite. Let's jump back over here. We had a is 2, b is 12, c is negative 14. So I can write that again here for reference. A equals 2, b equals 12, c equals negative 14. Now I'm going to switch colors so we can see when I plug these values in what it looks like, okay? So negative b, well, b is 12, so negative b is negative 12. We can write our plus and minus. B squared is 12 squared, and negative 4 times a, so I'm going to put this in parentheses for us, times a, which is 2, times c, which is negative 14. Okay, and I'll extend my radical. Now all of this is over 2a, which is 2 times 2. Okay. So let's go ahead and let's get the hard part out of the way. And typically the hard part's going to be in this radical. So 12 squared is 144. So we know we've got, and I'm just going to kind of shoot this off over here. So I'm going to put this right over here. So I know 12 squared is 144. I know that 2 times 4 is 8. So I can simplify this to minus 8, right? 2 times negative 4 minus 8 times a negative 14. So let's go through and do the math here. So 8, and this is how I do these types of multiplication. 8 times 10 is 80. And 8 times 4 is 32. 80 plus 32 is 112. So this turns into, and notice I've got a negative times a negative, so it is a positive value here. So this is 144 plus 112. And that's kind of ugly, so let's get rid of that. We've got 144 plus 112. Okay, 144 plus 112, I've got 100 plus 100, I know it's 200. 40 plus 10 is 50, 4 plus 2 is 6, 256. Alright, so now I've reduced this down to the square root of 256. Alright. How do I find the square root of 256? Well, we've covered this in early sections, but what we can do is we can use factoring, right? So let's go ahead and we'll factor 256. And so if I do that, I know it's an even number, so I get 2. And 256 is 128. 264. 2 and 32. 2 and 16. 16, I happen to know, is 4 times 4. Times 4. So again, we can make these factor trees look a bunch of different ways. 2 times 2, 2 times 2. So how many 2's do I have? I've got 1, 2, 3. Whoa, hold on. I wrote too many there. Let's go ahead and back up real quick, undo that one. So this one is 2 times 2, 2 times 2. There we go. So how many do I have? I've got 1, 2, 3, 4, 5, 6, 7, 8. So I've got 2 to the 8th over here. Okay. So now how do I find the square root of 2 to the 8th? Well, Interestingly enough, that's the same as 2 to the 4th squared. So now I see that this is just 2 to the 4th. Well, now I need to find what 2 to the 4th is. Well, 2 to the 4th is 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, it's 16. So lo and behold, we found the square root of 256 is 16. If we wanted to check that on a calculator, we certainly could. So let's go ahead and do that real quick. So we can go clear square root 256. Aha, 16, so we know we're doing things correctly, that's great. Let's jump back into our whiteboard over here, so I know I've got 16. So all of this is now simplified down after all of this work. And you can see how it takes a lot of paper. So I'm now into negative 12 plus and minus 16 all over 4. Okay, well, negative 12 plus 16 is 4. So I can say 4 divided by 4, I know one of these is going to be equal to 1. Negative 12 minus 16 is negative 28. And I'll write that over here. Negative 12 minus 16 equals negative 28. I can't forget about this 4, so I need to divide by 4, and that again equals my negative 7. So I got 1 and negative 7 again. 1 and, oops, we never wrote the negative, Dan. 1 and negative 7 there. So hopefully you've seen now all 3 methods. We've got factoring, completing the square, and the quadratic. Now what you may have noticed is that the quadratic and the completing the square are actually one and the same. They are identical. The quadratic is the solution to the standard equation when we complete the square. So they're actually one and the same. This just shows you all the mechanics of what's happening. This allows you just to plug in the solution. So hopefully that's helped. If you guys have any other questions, please let us know.